In this warm-up, you are multiplying. We have several fractions and whole numbers and mixed numbers to multiply together. Don't worry about reducing your answer or simplifying your answer. Just come up with an equivalent value. So 1 times 100 is 100, plus the 2 from the top makes 102 over 100. 3 times 10 is going to stay. Then we're multiplying. 102 times 3 is 306. 100 times 10 is 1,000. Like I said, don't worry about simplifying or reducing. For number 1, it says choose 2 rectangles from the set of 4 to complete parts A through C. So you're selecting 2 rectangles. I'm just going to work with the first 2. A says write a multiplication number sentence that represents the area of the first rectangle you chose. 4.8 times 5 equals 24. The multiplication sentence needs an equal sign. If it said expression, you could leave it without. Because it says sentence, we want that equal sign. To find the area of a shape, you do the base times the height, or sometimes they refer to it as the length and the width. So 4.8 times 5 equals 24. B says to write the sentence for the second rectangle you chose, which is 2.4 times 10 equals 24. C, consider the factors that represent the lengths and widths of the rectangles in the multiplication number sentences you wrote. Use these factors to describe how the rectangles are related. You can see here that the dimensions is twice in this category, but half over here. So the base is half the size, but the height is twice the size. So they have the same area. If you were to look at these, you can see 5 times 3 is 15. So if we split 4.8 into 3 parts, we get 1.6. So that our area remains the same. Two, choose 2 rectangles from the set of 4 to complete parts A through C. I'm going to work with the middle 2 this time. You'll notice all of them have the same height. We're going to start with the first rectangle we chose, which is 0.4 times 6 equals 2.4. And then B, for the second rectangle we chose, 0.04 times 6. Which had an area of 0.24. C says consider the factors that represent the lengths and widths of the rectangle in the multiplication number sentences you wrote. Use these factors to describe how the rectangles are related. Remember, I changed the language from length and width to base and height. So the height is the same. The base is 1/10 the size. 0.4 split into 10 parts would be 0.04. So the area is also 1/10 of the original rectangle. When multiplying decimals, we're thinking about the place values. You can see here that 7/10 or 0.7 is represented by filling 1, 2, 3, 4, 5, 6, 7 rows out of 10 rows, and 3/10 would be filling in 3 columns out of 10 columns. So then when we multiply them together, a 10th and a 10th, that gives us 100th. With 10 rows and 10 columns, we have 100 boxes. So our answer here is this part that's double shaded out of 100. So we have 3, 6, 9, 12, 15, 18, 21 hundredths. There are 21 boxes that are shaded with both colors out of 100 boxes altogether. Number 3 says use the 10 by 10 grid to complete the problem. Each side length of the grid represents 1 unit. On the grid, shade a rectangle with an area of 4.42 square units. So if we're creating a rectangle, I can't go 10, 20, 30, 42 because that shape would not be a rectangle. So we need to come up with a way to get to 42, creating a rectangle. So if I did 6, 12, 18, 24, 30, 36, 42. So now we need to write the multiplication sentence. In this direction we have, 1, 2, 3, 4, 5, 6, 7 columns shaded. So 7/10. And 1, 2, 3, 4, 5, 7 rows and 6 columns, which gives us 42 out of 100. Remember, we needed to create the rectangle. So we looked at how many rows and how many columns to get 42 out of 100. Use the 10 by 10 grid. Shade a rectangle on the grid. Write a multiplication number sentence using only decimals to describe the area of your rectangle in part A. Well, it comes out to 4, 8, 12, 16, 20, 24, 28. So that would be 0.28. That's 1, 2, 3, 4, 5, 6, 7 rows. And 1, 2, 3, 4 columns. So 0.7 times 0.4 is 0.28. Now to write that as a fraction, 7 out of 10 rows and 4 out of 10 columns is 28 out of 100 boxes. 7 times 4 is 28. 10 times 10 is 100. Here you can see 4 times 8 is 32. 10 times 10 is 100. So if we were to write this in a decimal format, 32 out of 100 would be 0.32. This one, 4 times 8 is 32, but instead of having 10 rows or columns, we now have 100. So 10 times 100 would be 1,000, which would be in the thousandths place. This is tenths, hundredths, tenths, hundredths, thousandths. You can think of it using the place value charts. You can see here tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. They're showing you here that the numbers, if you're multiplying 23 by 5.6 or 230 by 56 or 230 by 560, the numbers are the same, but the location of the decimal, or where those place values line up, changes based on what you're multiplying together. So here it says 23 times 5.6 is 128.8. They've multiplied this one by 10 to make it larger, but they've multiplied this one by a tenth to make it smaller. If this place value goes up by 10 and this place value gets broken down by 10, those two things counteract each other and we end up with the same result. Just like in the rectangles in the first part of the lesson, when we doubled the length and took the width in half, we still got the same area. So this shows 17 times 348. It's 5.916, which is not a true number sentence. So we need to figure out where we could place the decimal to make this true. If I did 17 times 3 and a little bit, well, 17 times 3, 3 times 7 is 21, 3 times 1 is 3, plus 2 makes 5. So 17 times 3 would be 51, but not 5. So in order to get it to be 5, I need to move that place value even further. Now let's see if I did 17 times 0.3. 3 times 7 would be 21. 3 times 1 is 3, plus 2 makes 51, but there's a decimal there, so we would need a decimal in our answer as well, which gets me close to 5. Now if I did the whole number of 0.348 instead of just 3, that would get me this value. I just used the 3 to help me approximate where to put my decimal. So let's check. 8 times 7 is 56. 7 times 4 is 28. Plus 5 is 33. 7 times 3 is 21. Plus 3 makes 24. 1 times 8. 1 times 4. 1 times 3. That gives me the whole answer here. And I have 1, 2, 3 spots. 1, 2, 3 spots. For problem 5 and 7, order the expressions from least to greatest. All of them have a denominator of 1,000, and all of them are multiplied by 16. So the least is going to be the one with the lowest numerator, and the greatest is going to be the one with the greatest numerator. So this will be 16 times 500 over 1,000. Then next up would be 505 over 1,000. Then 510. And then lastly 520. Least, greatest. All of these also have 16, so I can ignore that part of it. Then to find the least, I want the one with the lowest decimal. This is 505. This would be 52. If we want the same number of decimal spots, we can add zeros to the end. So this would be like 500, 510, 520, 505. So to find the least, we would want the one that has 500. Then would 510 be next, or 505? 505 is the next smallest. Then 510. And lastly, 520. Number 7, the 16s are not the same. Those have changed, so we have to be paying close attention on this problem. This is 16 with one place value, or one decimal, so this is broken down into a tenth. This one I have 2 here and 2 there, so that's 1, 2, 3, 4 spots that it's broken down by. This one has gotten bigger by 10, but then broken down 1, 2, 3, 4 spots. But that one would divide out one of them, so then only 3 spots. This one has 2, which would be 100th. So the least is going to be the one with the most amount of decimals. The least is the smallest pieces. So this one's broken down into tenths, hundredths, thousandths, 10,000ths. Then we have the thousandths, 4 decimal spots, but make this one bigger, so really 3. Then this one has 2 decimal spots. And this one has 1. And that's the end of this lesson. Go ahead and check back here for any updates.